did start talking about similarity on Thursday, but it was a little bit up in the air. And I mean, I didn't make proper notes or anything. I just kind of sort of almost reminded you that you have done similarity before, that you did similarity in grade 9. Got it? Okay. So we're going to formally do it quite quickly. Just a recap, but if there's anything you don't understand, I want you to please put your hand up, stop me, we'll talk about it. Okay. So we are going to specifically deal with similarity of triangles. And for two triangles to be similar, we are saying if I have triangle ABC and triangle DEF, and it is given to me, or I can at least prove, remember either they have to give this to me or I have to prove it, that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. And I reminded you guys on Thursday, technically speaking, you don't have to prove all three are equal. You just need to prove two of them are equal, then the third pair will always be equal because of sum of angles of a triangle or interior angles of a triangle. Got it? Then the deduction that can be made from this is that triangle ABC is similar. So please remember, similar, 3 vertical lines, not like congruency, which is 3 horizontal lines. Please don't confuse the two. So then triangle ABC is similar to triangle DEF, and the reason is either angle, 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 as we taught you in grade 9, or you can use the reason equiangular triangles. But I just think angle, angle, angle is easier. Okay. Then, once you've established that the two triangles are similar, you know that the corresponding sides are in proportion. So in order to get those corresponding sides, you have to remember, and this was told to you in grade 9, that when you make that statement of similarity, angle A, which is equal to D, must both be in the first position. Angle B, which is equal to angle E, must both be in the second position. And angle C, which is equal to angle F, must both be in the third position. So the equal angles must correspond in the order that you write the triangle down. Got it? That is a rule. Otherwise, you're going to be penalized for your notation. And the good news, at least, and this is something I did teach my grade 9s, but you might have forgotten, is if they ask you to prove two triangles are similar, so if they say, prove triangle PQR is similar to triangle STU, then what have they actually given away to you? What have they told you? Yes. And through the notation, what do you know? Yes, but more than that, you know which angles are equal to which angles. They can't ask you to prove that similar to that unless they use the correct notation. So if they use the notation ABC, prove triangle ABC is similar to triangle DEF, you know you have to prove angle A equal to angle D, angle B equal to angle E, and angle C equal to angle F. So that's actually a dead giveaway. You just have to find the reasons why they are equal. You know they're equal, you just have to find the reasons. Okay. Then also, that notation helps me to write down the proportionality, because a lot of people don't seem to understand. Similar triangles are triangles of which the sides are in proportion to each other. Remember, I kept on telling you on Thursday, same shape, different size. So it's exactly the same shape, but that means that if the one side, this side, is twice as long as this side, then that will be twice as long as that one. This will be, you understand? All the corresponding sides will be in the same proportion. Now, those proportions you can very easily see from that similarity statement, meaning AB over DE there is equal to BC over EF there is equal to AC over DF there. But just like I explained to you guys with the proportionality theorem, that's not the only statement we can make. We can also do this. If I say, for instance, AB over AC, what will AB over AC be equal to? Do the jump. Can you see it? AB over AC will be equal to DE over DF. It doesn't have to go from one triangle to another triangle. You can do a little pattern in the one triangle, but the rule is if you do a pattern in this triangle, you have to repeat the pattern in the other triangle. So that's why AB over AC is DE over DF. But then, unlike this statement, there won't be another one that it is equal to. Do you spot that? Because I've repeated the pattern, I'm done. You can also go and you can say something like the following. You can say AC over BC is going to be equal to what? DF over EF, absolutely. So unlike when you guys were in grade 9, we always did the pattern from the one triangle to the other triangle. We said that corresponding side over this corresponding side. We always did this statement. Do you understand? But now that you understand the whole idea behind proportionality, you can make these statements as well, as long as you follow the same pattern. Got it? Stick to the same bounces. So that's similarity. Let's look at some examples. In the first example, they say, in the diagram, PA is parallel to BC. So we put that on the diagram. And angle B1 is equal to angle C. That's been given over there. Now, the first thing they ask under A is prove that triangle PAB, and I'll highlight that for you guys. There. Is similar to triangle ABC. And the lovely thing you've got there is because they made this statement, prove that the first triangle is similar to the second triangle. They've actually told you which of the angles correspond. So that means in the pink triangle, you have to prove that angle P is equal to angle A in the green triangle. You have to prove that angle A over here is equal to angle B over here. And you have to prove that angle B over here is equal to angle C over there. Got it? So they've told you which angles are supposed to be proven equal to which ones. And the good news is, always start with what has been given. So the very first statement you can make is you can make the statement B1, and I'm going to just write it properly, in triangle PAB and triangle ABC, angle B1 is equal to angle C, and my reason there will be given. Now the next one is going to be A1 is equal to B2. Why is angle A1 equal to angle B2? Alternate angles, because they gave me the two lines as being parallel. Do you spot that? So I can say alternate angles because PA is parallel to BC. Don't forget those parallel lines when you make statements like alternate angles, corresponding angles, co-interior angles. And then the very last one is always going to be whatever is left. In this case, angle P, which is equal to angle A2. And there your reason will always be sum of angles for triangle or interior angles for triangle. And then I can say, therefore, triangle PAB is similar to triangle ABC. And the reason is angle, 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 or equiangular triangles. It's up to you what you want to write. Okay. Now, the next question then says, please prove that PA to AB, or PA over AB, because a ratio is the same as a fraction, is equal to PB to AC. Now, let's quickly look at that. PA is over here. AB is over there. So what will PA over AB be equal to automatically? AB over BC. Do you see the pattern? PA over AB will be AB over BC, which is not exactly what I wanted to prove, but at least I can start there. Do you agree? And my reason there, you can either use similarity or you can use similar triangles. Now, like I said, what is missing there? We've got AB over BC. We want PB over AC. Well, actually, I can do that quite easily. I just have to rearrange it. Do you guys understand what I'm saying? Okay, let's look at it like this. I've got PA over there, I've got AB over there. So I've done them like that. Then I want PB, so PB is over there. And then I want AC, AC is over there. Can you see that? So I could actually go and I could do the following. I could start by saying, instead of using that as my statement, I could have said PA over PB. So PA over PB is equal to AB over AC. And then I've got the corresponding side. Oh, sorry. This is clearly way too early on a Monday morning. Okay. Let me show you what I'm talking about. If I look at PA over PB, so I change this one to PB, then I can look at there AB over AC. Everybody got that so far? So now I've got the PA that I want over here. PA is over there. I've got the PB that I want. It's over there. I've got AB I want over there. I've got AC that I want over there. So all I need to do is quickly swap it. You understand? And you don't even really have to do the algebra there. You just write down that first statement, and then what do you do next? Write down the statement they want. Because you know for a fact that this statement is correct based on the pattern. You guys agree with that? So if your first statement is correct based on the pattern, then automatically you can algebraically get to the next statement. So you don't have to go and write 3 or 4 steps. You can actually just jump straight there in one step. If you're not happy with jumping there in one step, do a little bit of algebraic manipulation, but I'm perfectly happy if you then do this. Because what you would have had to do is, I think, you would first have to cross multiply, and then you'd have to go and redivide to get it to that format. You understand what I'm saying? So you can check. Those of you who don't just like going automatically there without proving that the math leads you there, just check. Cross multiply, redivide, and you'll get there in one go. Okay, next one. You guys try this one on your own.
Could you explain something to me in the...
Oh yeah, I'll come to you just now. Yeah, absolutely. Sure. Right. You should be able to do it in 2 steps if you pick the right sides. Did you spot that? So, how did I know to pick the right sides? I saw everything that I needed. I needed AB twice. So I've got AB over there, but I've got AB over there as well. I need PA, so I've got it over there, and I need BC, so I've got it over there. So I just went, and by the way, this was not the only way you could have done it. There were other ways to do this as well. So I said PA over AB is equal to AB over BC, still because of the similar triangles. Got it. And then I just did that cross multiplication. AB times AB is AB squared, and PA times BC is PA times BC. Everybody got that so far? Good. So try the next one on your own.